Nonlinear systems of equations, let's solve these things. That's the goal. So you've solved linear systems of equations. Remember, when you solve two equations, two unknowns, they graph to be lines. And where they intersect, that's the solution, right? That point of intersect. If there is a single point of intersection, that's the solution. Remember that? Same thing here. We're going to look at nonlinear systems, so graphs that don't graph to be lines, but they're going to be two equations, two unknowns, so they do graph to be curves in the xy plane. And a solution would just be where they intersect. Example, solve the system y equals x squared. What does that graph to be? Y equals x squared. It's a parabola, a happy U-shaped parabola, right? So it's nonlinear. Oh, the other guy, though, is familiar territory. 3x minus y equals 2. What does that graph to be? It's a line, right? So what are the possibilities? Now, you guys should know right off the top of your head that y equals x squared looks like that when you graph it, right? That's a graph you should have in the library of graphs in your head. And then, a line? Well, I think it's going to have positive slope, because if I put it in y equals mx plus b form, I would end up subtracting 3x and multiplying through by that negative. So it'd be a positive slope. So I'm not sure exactly where the line is, and I wouldn't expect you guys to be sure of that either. But I do know that the slope is positive, which means it goes up from left to right. So what are the possibilities? How could the parabola and the line intersect? What's the maximum number of points they could intersect in? 2. You see the solutions there, there, and there? So you could have as many as 2 solutions, right? Because the solutions are the intersection points. Does everybody see that? Okay, well, let's erase those intersection points. Is there any way to get one solution? Couldn't we just barely? Yeah, that's close enough. So if it doesn't quite make it, just make the point bigger, right? So do you guys see that there's a way to get a single intersection point? We say the line is tangent to the curve when that happens, when it just kisses it at one little point. So there's a way to get one. You could have 2 solutions. You could have 1 solution. Could you get no solutions? Very easily, right? Since y equals x squared is a parabola opening up, the line could possibly lie, as far as we know, below the parabola entirely, right? No intersection point, so no solution. So you could have no solutions. You could have 1 solution. You could have as many as 2 solutions. So that's kind of different, but at the same time, we're just looking for intersection points. That's the same as the systems you've solved in the past with 2 unknowns and 2 equations. Okay. In the past, symbolically, you've had a couple of ways to solve systems of 2 equations, 2 unknowns. Do you remember what they were? This is the review part. Substitution and elimination. Elimination won't work so well here because you have to have kind of a correspondence between the unknowns, right? In other words, in the second equation, you don't see an x squared, right? So there's no way to eliminate like the x squared. I suppose you could eliminate the y's. But what would work better here is substitution. Substitution will still work. Check it out. I know that from the top equation, y equals x squared, right? Couldn't I just plug that in the bottom equation for y? Isn't that the substitution method? Y equals x squared. Plug it in the bottom equation for y. Okay, what do we get if I do that? I get 3x, that hasn't changed, minus x squared equals 2. And now that's an equation with a single unknown in it. That's the whole reason behind substitution, right? That we know how to solve. What kind of equation is that? 3x minus x squared equals 2. Begins with a Q. Quadratic, right? It's a polynomial equation degree 2. That means it's a quadratic equation. We know how to solve it. What do? Let's set it equal to 0. So I could bring 2 over to the other side, but I'm going to want to rearrange things, right? Descending powers of x, so what would it look like? Negative x squared plus 3x minus 2 equals 0. All right, because these guys go away. And then when you're dealing with a quadratic equation, it's nice to have the leading coefficient positive. So what could you multiply through by to make the x squared, not negative x squared, but positive x squared? You could just multiply both sides by -1. Of course, you multiply 0 by -1, it doesn't do much, right? It still remains 0. And what do you get on the left side? X squared minus 3x plus 2. Ooh, okay, so what methods, again, I'm pouring review in here, what methods do we have for solving a quadratic equation? If you're feeling like you haven't worked hard enough lately, you could maybe solve by taking roots, right? If you're looking for maybe the hardest way to do it, solving by taking roots. Well, I'm sorry, what do you have to do before you solve by taking roots? Complete the square, right? So yeah, that would be the hardest way to do it. Completing the square and then taking roots after you complete the square. And then the second hardest way would probably be the quadratic formula, which is kind of the go-to method if you're not sure how to solve it, right? What would maybe be the easiest method if it works? It doesn't always work. Factoring. Is it worth a try factoring it? When there's a 1 in front of the x squared, it's almost always worth a try, because it's very systematic and very quick to see if it factors. So you unfoil it, right? The first multipliers have to multiply together to make what? X squared, so they have to be x and x. 2 is a prime number. You don't have a whole lot of choices there, right? Except you do have a minus in the middle. So if you put 1 and 2, you have to make an adjustment. They both have to be what? To get a plus 2 and a minus in the middle, they both have to be minus. And then just check that minus 1 and minus 2, that their product is positive 2. What do they have to add to be? Negative 3. They do, so you know it's the right factorization. Okay, so what do we do with both factors? Set both factors equal to 0. And you solve. So you get x equals 1 or x equals 2. Now, well, you have to not stop here, because you have to remember you're looking for intersection points. So there's going to be a y-coordinate that goes with that x-coordinate of 1. There's going to be another y-coordinate that goes with that x-coordinate of 2. Those are the x-coordinates of 2 separate points of intersection. So we're in that first situation graphically. We're in that first situation where the line is going to intersect in 2 spots, right? So if I want to get the y-coordinate that goes with an x-coordinate of 1, what do I do? Yeah, which equation? Now you could plug in either equation. You could plug x equals 1 in either equation. Which one's easiest? Definitely. It's already solved for y, right? Okay, so y equals, let's see, 1 squared? I think that's going to be 1, isn't it? So what's the ordered pair then? The solution? 1, 1? Could you check that? I mean, we're not done with this one, but could you check that? If you plug a 1 in here and a 1 in here, is that a true statement? Okay. What if you plug in a 1 in here and a 1 in here? Will you get 2 when you do the arithmetic? Yeah. So you know that's one correct solution. Okay, you also have an x-coordinate of 2, a first coordinate of 2. It's not always going to be x and y. It goes in alphabetical order if it's not x and y. So m and n, it might be. M would be the first coordinate, n would be the second coordinate. Okay, same thing. To get the y-coordinate that goes with an x-coordinate of 2, can I just plug in right there? What do I get if I do that? Y equals 2 squared or 4. Okay, so what's the ordered pair solution for that? 2, 4. So the 2 intersection points are 1, 1 and 2, 4. The 2 solutions are the points 1, 1 and 2, 4. Now I didn't check the point 2, 4, but the x equals 2 and y equals 4 would have to satisfy both equations as well to be a solution. But you can always check your answers on any system of equations.